Hello students, today in this video we are going to do chapter number 9, exercise 9.2 from Math Exemplar. So in the question number 1, a chord AB is given which subtends an angle of 60 degree at the center of the circle, and also two tangents from point A and B are given, and we have to prove that this angle, if it says if angle AOB is 60 degrees, so angle ACB should also be 60 degrees. So what can we say about the measure of the angle OAC? AC is the tangent to the circle, and A is the point of contact, and OA is the radius. So it means OAC will be 90 degrees. Similarly, angle OBC will also be 90 degrees because BC is the tangent to the circle and OB is the radius. So now in quadrilateral, AOBC, we know the measure of angle OAC and OBC both are 90 degrees. 90 plus 90 plus angle AOB, that is 60 degrees, plus angle ACB, should be sum of all the four angles should be equal to 360 degrees, and so it means angle ACB is 120 degrees. So hence angle ACB is 120 degrees. It is not 60 degrees. So it means this statement is false. Now moving to next question. In this question it says the length of a tangent from an external point on a circle is always greater than the radius of the circle. This statement is also false because the length of a tangent from an external point may or may not be greater than the radius of the circle. It is not always greater than the radius. Now in the question number 3, it says the length of a tangent from an external point P. External point P is given. PT is a tangent on the circle with center O is always less than OP. It says we have to prove that PT is always less than OP. Okay, so now if we see that PT is a tangent to a circle and T is a point of contact, and what can we say about the measure of angle OTP? Yes, angle OTP is 90 degrees. So it means the triangle OPT is right angle triangle. And so what? So it means OP is the hypotenuse in this triangle, right? So in a right angle triangle, hypotenuse is always greater than any of the other two sides. So it means OP, that is hypotenuse, is greater than PT. So it means the statement is also false. Now in question number 5, if angle between two tangents drawn from a point to a circle of radius A and center O is 90 degrees, then OP is A times root 2. So it means it says if angle between two tangents, that is this angle TPR, is given 90 degrees, and O is the center of the circle, and we have to prove that this OP is, the length of this OP is A times root 2. So now what, it's given that angle TPO is 90 degrees. So what can we say about these two angles, this and this? Yes, angle TPO and angle RPO. They both are equal angles. Why these two are equal angles? Because these two triangles PTO and RPO are congruent triangles, or we can say that the line OP bisects the angle RPT. That is why these both angles are 45 degrees. Now also this triangle PTO is 90 degrees because PT is a tangent and OT is the radius. So in this angle PT is 90 degrees. So it means triangle PTO is right angle triangle. So in the right angle triangle PTO, this so if, now we will use here trigonometry. So OT is the perpendicular and OP is hypotenuse. So it will make which angle? Yes, sine 45. OT is the perpendicular, OP is the hypotenuse. So it means OT over OP will be equal to sine 45 degrees. And OT is given A, and we have to find OP, and the measure of sine 45 is 1 root 2. So it implies that it implies that OP will be equal to A times root 2. So it means the statement is true. Now we will move to next question, question number 6. In this question, it is given if angle between two tangents drawn from point P to a circle, if angle between two tangents drawn from point P to a circle of radius A, radius is given A, uh, and center O is 60 degrees. So this angle is given 60 degrees. Then OP is A root 3. So we have to find the length of OP here. So again, it's given here angle, the measure of angle TPR is 60 degrees. So, and also angle TPO and angle OPR are equal because OP is bisecting the angle TPR. So it means they both are equal to 30 degrees. These both are angles are 630 degrees, and this angle PTO is 90 degrees because PT is a tangent to a circle and OT is radius. So in the right angle triangle PTO, we will use trigonometry here. So it means OT over OP will be equal to which ratio? It will be equal to sine 30 degrees because OT is perpendicular and OP is hypotenuse. So OT is given was A and we have to find OP, and sine the ratio of sine of 30 is 1 over root 2. So it implies OP is equal to 2A. So it means the statement is false. Now in question number 7, it is given the tangent to the circumcircle of an isosceles triangle ABC. So ABC is an isosceles triangle with AB and AC are two equal sides, and this triangle is circumscribed inside a circle, and in so we have is parallel to BC. So if we draw a tangent from point A, EF, this tangent EF is parallel to BC. So we have to prove EF is parallel to BC. So what can we say about this angle EAB and ACB? Angle EAB and ACB. And angle ACB. Yes, these two angles are equal. Why these are equal? Because angle between tangent and chord is equal to angle made by chord in the alternate segment. AB is the chord here, and this angle EAB is the angle between the chord and the tangent. This angle EAB is the angle between the chord and the tangent, and angle ACB is the angle made by the chord in the alternate segment. So if these two angles are equal. Also, if we observe in triangle ABC, it is given that AB is equal to AC. AB and AC are equal, so it implies that angle ABC will be equal to angle ACB. Angle opposites to equal sides are equal. So let's name this as equation 1. This is equation 2. And from equation 1 and 2, we can say that angle EAB is equal to angle ABC. So if we observe, it says that we have proved these two angles are equal. So what kind of angles are these? Now we have proved that these two angles are equal. Yes, these two are alternate interior angles. So it means the lines EF and ABC are parallel. So it implies angle line EF is parallel to BC. So it means the statement is true. Okay, now in the next question it says if a number of circles touch a given line segment PQ at point A. So there are different circles are given here, and all the circles are touching a line PQ at point A at this point A. Then their centers lie on the perpendicular bisector of PQ. So we have to prove that the centers of this circle lie on the perpendicular bisector of PQ. So we have drawn different circles here, S1, S2, S3 and S4, and C1, C2 and C3, C4 are their centers respectively. And so now if we join these points, C1, C2, C3, if we join all these points to this A. So what angle is this? If we take the angle C1AQ, yes, this will be 90 degrees. Angle C2AQ, this will also be 90 degrees. Why? Because PQ is a tangent and A is a point of contact, and C1A is the radius, C2A is the radius. So it means these are all angles will be 90 degrees. So, and also we know that if we draw a line from the center of a circle, then the line is always perpendicular tangent line, but it does not bisect the line segment. So it means it is perpendicular to the line segment PQ, but it does not bisect it. So it means the statement is false. And now in next question, it is given if a number of circles pass through the endpoints P and Q of a line segment PQ. There's a line segment given PQ and more than one circles are passing through this point PQ. Then their centers lie on the perpendicular bisector of PQ. Okay, so it means PQ is the chord to these circles C1 and C2, right? And if we draw the perpendicular bisector of a chord that will pass through the center. As we know that the perpendicular bisector of a chord of a circle always passes through the center of a circle. So it means the perpendicular bisector of PQ will always pass through the center of the circle. So it means this statement is true. Now in the next question 10, it is given AB is the diameter of a circle and AC is its chord. This AB is the diameter, AC is the chord, and angle BAC, this angle is given 30 degrees. And if the tangent at C, at this point C, intersects AB extended at D, at this point, then we have to prove that BC is equal to BD. So it says this BC is equal to BD. BC is equal to BD, these two. So to prove this, what if we prove that angle BCD and BDC are equal, then automatically BC will be equal to BD. So now it is given that this angle OAC is given to us 30 degrees. And so what can we say about this angle BCD? Angle BCD. See, angle this BC is the chord to the circle, and so it and CD is the tangent to the circle. It means angle BCD will be equal to the angle OAC. These two angles, this angle and this angle, these both will be equal because angle between tangent and chord is equal to the angle made by chord in the alternate segment. So it means angle BCD will also be 30 degrees. Now also we know that angle OCD, this complete angle will be 90 degrees because CD is the tangent to the circle and OC is the radius. So angle OCD will be 90 degrees. And in this triangle OAC, OA and OC are equal. Why these are equal? Because these are radius to the circle. So it means angle OAC will be equal to angle OCB. So it means angle OCB will also be 30 degrees. So this angle is 30 degrees. So from here we get that ACD, angle ACD will be equal to 30 plus 90. So it means this angle will be 120 degrees. Okay, now in triangle ACD, we know that angle A is 30 degree, angle C is 120 degree, and from here we can find the measure of angle ABC, and by angle sum property we can say the sum of all three angles is 180 degrees. From here we can get the measure of angle ADC is 180 minus 150. So angle ADC is 30 degrees. So it means this angle is also 30 degrees. Earlier we got that this angle is also 30 degrees. So now in triangle BCD, we know that BCD and BDC both are 30 degrees. So it means BC is equal to BD. Hence, BC is equal to BD. Hence, this statement is true. Hope this video was helpful to you. Don't share to like and share it. Thank you.